We describe a method to synthesize motions for characters that are pushed, perhaps by a user, a game engine, or a collision. We want to produce motions that recover from the push and maintain balance. We start with recorded examples of an actor being pushed by someone else, like these motions. A recorded example is good for only one particular push. However, we deform the example to get a response to a different push. Here are 3 deformed examples. Each responds to a push from a different direction. Our deformation model is parametric. Some parameters generate good-looking motions, and some parameters generate bad-looking motions. Here are another 3 motions obtained by deforming the original sequence with different deformation parameters. These motions do not look realistic. When a push arrives, we choose a suitable example, deform it appropriately, and transition onto the result. This transition is good because it looks realistic. Some transitions lead to bad motions. This transition is bad because it doesn't look realistic. We introduce an oracle that learns to predict the goodness of a combined deformation and transition. The oracle checks whether the motion looks like a realistic response to a push from the specified direction. This is an example motion synthesized using our algorithm consulting the oracle. We compare to a baseline algorithm that picks an example by checking that the push is numerically close and the cut from the original motion to the response is small. This often creates motions that respond to the wrong push. The baseline response is on the left, and our method is on the right. Our method responds better to the actual push. The deformations are important. In the middle, we show what happens if we don't deform the example. In this case, the actor responds to the wrong push. Once the oracle is trained, the synthesis process is interactive. This is a real-time screen capture from a desktop PC. The character can be pushed anytime from any direction. The oracle finds the transitions and deformation parameters that yield good motions. Our method also allows repetitive pushes. This is an example application where a crowd of people is confined in a restricted space. When they bump into each other or the boundary of the space, they are pushed back.